y'all? Let's learn about more linear equations and shading. Okay, so we talked about slope, about how slope tells you about the steepness of a line. Well, you can compare the two lines by talking about their slope. If we have slope and y-intercept, you can write the equation in slope-intercept form. You can also write it in point-slope form if you have the slope and any point. So here is point-slope form. The equation is, if you have this point, x1, y1, so that's actually going to be numbers, like 3, -2, or something. And then a slope m, let's say your slope is like 1/2. So those are going to be your numbers, right? So point slope form is y minus the y value of your point equals m, the slope, times x minus the x value of your point. And this should look a little bit familiar to you. If you remember the slope formula, the slope, if we don't know the slope but we have 2 points, we can do subtract the y values, divide by the difference of the x values, and that gives us the slope. Well, if you substitute, instead of like saying I know what the y value of my second point and the x value of my second point is, if we just call that the general point, so any point on the line x, y, then we get, if we were to multiply both sides of this equation up here by x minus x1, so they would cancel here. Alright, they're going to cancel here. And then we get y minus y1 left equals m times x minus x1. So an example, so if I really did have a point 3, -2, and I knew that the slope of this line going through that point was 1/2, it would be y minus -2, which turns into y plus 2, equals m times, so 1/2 times x minus x1. So that would be x minus 3. So that's the point slope form of that line. Okay, so a line passes through -5, 2 with a slope of 3/5. What is an equation of that line? So we're going to use point slope form. Y minus the y value of the point equals the slope times x minus the x value of the point. So we're going to substitute 3/5 for m, because that's the slope, and then at x1 we'll substitute -5, and then y1 will substitute 2. So y minus the y value was 2 equals the slope 3/5 times x minus the x value, which was -5. Now we'll simplify a little bit. Minus a -5 is +5. And so an equation for that line is y minus 2 equals 3/5 times the quantity x plus 5. And that is the point slope form. So what is an equation of the line that goes through the point 7, -1 with a slope of -3? So this is my x1, this is my y1, and this is my m. So y minus y1 equals m times x minus x1. This you should have in your notes, and you should do it enough times to where you just kind of have that memorized. But you should always have it in your notes just in case you forget, because you will need to do this on the test. So I'm just going to substitute in. The y and the x are going to stay y and x, but the y1, the m, and the x1 are all going to get replaced with these values. So y minus -1 equals m, which is -3, times x minus x1, 7. And simplify the minus -1, that's +1 equals -3 times x minus 7. Now, I want you to realize that you could really easily change this into slope-intercept form. All you would have to do is distribute the 3 and then subtract 1 from both sides. So for fun, I'm going to do that. Negative 3 times x is negative 3x. Negative 3 times negative 7 is plus 21. Then if I subtract 1 from both sides, I get y equals negative 3x plus 20. So for this same line, now I got 2 different equations for that line. One in slope-intercept form and one in point-slope form. And I could use either one of these to graph it. If I was going to graph with slope-intercept form, I would start at up 20 on the y-axis, and then I would go down 3 over 1, down 3 over 1. So it would be like something like that. And if I was going to do it from point-slope form, I would start at the point 7, negative 1, over 7, down 1, and then I would use the slope of negative 3 to make the line go that way. So you can use either one. It's lots of fun. Okay, so what if they just give us 2 points? Well, heck, what am I going to do with that? I know 2 points. I need an equation written in point-slope form. So I could substitute the slope in either point into the point-slope form. So do I know how to find the slope given 2 points? I do. So if I call 3, 2, x1, y1, and if I call 5, 8, x2, y2, then I can use the slope formula, which was m equals y2 minus y1 over x2 minus x1. So 8 minus 2 over 5 minus 3, that's 6 over 2, so my slope is 3. Now I just pick a point. Picking 3, 2, I guess. And I do y minus y1, which is 2, equals the slope, which was 3, times x minus x1, which was 3. So there is point-slope form. Alright, so go ahead and pause. See if you can do 2a and b. Alright. A line passes through negative 5, 0 and 0, 7. What is an equation of the line in point-slope form? So I got points. I can call this x1, y1 and x2, y2. And I can find the slope. M equals y2 minus y1 over x2 minus x1. So that is 7 minus 0 over 0 minus negative 5. 7 minus 0 is 7. 0 minus negative 5 is positive 5. So my slope is 7 over 5. So y minus 0 equals 7 over 5 times x minus negative 5, which is x plus 5. So what would another equation be in point-slope form of this line? Well, it would have the same slope, but say we use 0, 7 as our point instead of negative 5, 0. It would be y minus 7 equals 7/5 times x minus 0. So it doesn't matter which point you use. These might look like totally different equations, and they're different equations, but they describe the same line. And I could prove it to you. You want to see? So here are our 2 different equations, and I will show you how they describe the same line by putting both of them into slope-intercept form. So I'll start by distributing here. So we got y minus 7 on this side equals 7 over 5 times x. And then 7 over 5 times 0 is 0. So plus 0, but I don't really need to write that. But I can add 7 to both sides, and I get y equals 7 over 5x plus 7. So if these are really the same line, they should have the same slope and the same y-intercept. Alright, so for this one, y minus 0 is just y. And when I distribute the 7 over 5, I get 7 over 5x. And then when I multiply 7 over 5 times 5, that's like 5 over 1. And you can think about it as the 5's canceling, or you can think about it as 35 over 5, which is 7. So that just shows you that it doesn't matter which point I use, these two equations are describing the same line. The line with a slope of 7/5 and a y-intercept of 0, 7. Okay, so there's another form that we can put our linear equations in, standard form. So ax plus by equals c, where a, b, and c are real numbers, usually integers, and usually we try to make a positive. So we want the x term to be positive. It doesn't have to be, but it's usually nice if we do that. I usually do that, and so I want you to do that. Not every teacher will require you to do that, but your weird Algebra 2 teacher named Mr. McWhorter will require you to do that. Okay, so here's a little summary. We started by learning about slope-intercept form. You know this, you will use this one when you know the slope and the y-intercept, right? The slope is m and the y-intercept is 0, b. And we got point slope form now. If we know the slope in one point, or if we just have 2 points, we use that one. And then standard form is when a, b, and c are real numbers, usually integers, and a and b can't both be 0. Otherwise, you don't have an equation. You just have a number. You don't have any x or y. Alright, so let's put this equation in standard form. And see how they say use integer coefficients? That's what I'm talking about. Depending on the author of what book you're using, some of them won't even call it standard form unless they're integer coefficients. Okay, and that's the way I learned it, so that's the way you're going to learn it. Okay, so how would we put this into standard form? Well, we can get the x and the y both over here by subtracting 3/4 x from both sides of the equation. Okay, so 3/4 x minus 3/4 x is 0. So we got negative 3/4 x plus y equals negative 5. So what should we do next? We want to have integer coefficients, and you and I would like our x coefficient to be positive as well. So what we're going to do is we're going to multiply both sides of the equation by negative 4. So over here, when I multiply by negative 4, when you multiply by the fraction, you might want to think about it as negative 4 over 1. And then over here, we're going to also multiply by negative 4. So negative times negative is positive. These 4's will cancel out, so I'm just going to have positive 3x. And then negative 4 times y is negative 4y. Negative 5 times negative 4 is positive 20. So here we have a nice, pretty standard form equation. And we got a positive x coefficient, which is always nice. So check out number 3. Let's find an equation of this line in standard form. Go ahead and pause and give that a shot. Alright, I hope you were able to figure that out. Here's what we got. We got y equals 9.1x plus 36. And what I'm going to do right now, y equals 9.1x plus 3.6. So I'm going to get rid of these decimals. If I was to multiply both sides of this equation by 10, I would get 10y equals, and 10 times 9.1 is 91x, plus 10 times 3.6 is 36. Then I could subtract 91x from both sides to get the x's off that side. So I would have negative 91x plus 10y equals 36. And then just to make it nice and pretty, I'm going to multiply both sides by negative 1 so that my x coefficient is positive. 91x minus 10y equals negative 36. So there's our nice, pretty standard form equation. And your secret phrase for this lesson is Han Solo. Han Solo. Okay. What are the intercepts of 3x plus 5y equals 15? And graph the equation. Well, heck, do we remember from Algebra 1 how to find the intercepts? What is an intercept? An intercept is the point where the line crosses one of the axes. And the neat thing about the axes is that on the x-axis, the y value is 0. Because if we were above the x-axis, the y value would be positive. If we were below the x-axis, the y value would be negative. So on the x-axis, the y value equals 0. And then on the y-axis, the x value is 0. So because if x was positive, we'd be off to the right, and if x was negative, we'd be off to the left. So to be on the y-axis, our x value has to equal 0. So we can find our x and y intercepts by just setting y equal to 0 or x equal to 0. Okie dokie. So we'll set x equal to 0 to find the y-intercept. So we just substitute a 0 in for x. 3 times 0 plus 5y equals 15. Well, 3 times 0 is 0. So 5y equals 15. Divide both sides by 5, and we get y equals 3. So if we look at our graph, we got the point 0, 3 over 0 up 3. Boom, there is our y-intercept. Okay, well, let's find our x-intercept. For the x-intercept, we set y equal to 0. So it's going to be 3x plus 5 times 0 equals 15. 5 times 0 is 0. So we get 3x equals 15. Divide both sides by 3, and we get x equals 5. So we got the point 5, 0. Our x value was 5, our y value was 0. So let's plot that point. Over 5, up 0. Boom. We've got 2 points, and a line is defined by 2 points. So, whoosh, draw a line through it. Sweetums. So, see if you can do this guy right here. Alright, so if we want to find the y-intercept, we set x equal to 0. So 2 times 0 minus 4y equals 8. 2 times 0 is 0. 0 minus 4y is negative 4y. Divide both sides by negative 4. Whoopsh, whoopsh, and we get y equals negative 2. So 0, comma, negative 2 is our point. Right about there. If we set y equal to 0, we'll find our x-intercept. So 2x minus 4 times 0 equals 8. This is 0, so we get 2x equals 8. Divide both sides by 2, and we get x equals 4. So we get this point 4, 0. And then we draw a line through them. Whoosh. Not too bad. So let's take a note here. Parallel and perpendicular lines. This is something that we learned in Algebra 1, but it's always good to review. Parallel lines have equal slopes. We can't talk about the vertical lines because they have undefined slopes. Okay, so but we can talk about every other kind of line, and there's infinity of them. So parallel lines are going to have the same slope. So m1 equals m2, and then b1 does not equal b2, meaning they don't have the same y-intercept, because if they had the same y-intercept, they'd be the exact same line. Perpendicular lines have slopes that are negative reciprocals, which means that if you multiply them, you get -1, which basically means that one slope is the negative reciprocal of the other slope. So for example, if this red one, if this slope was like up 2 over 1, so if m1 was 2, then m2 would be negative reciprocal, so that if you multiply them together, you would get -1. So basically, you just think about it as a fraction, flip it over, and change the sign. Okie dokie. What is the equation of each line in slope-intercept form? Ding! The line parallel to y equals 6x minus 2 going through the point 1, -3, so that's going to be our x1, y1. And identify the slope, use point slope form, rewrite in slope-intercept form. So, identify the slope. The slope is 6, right? This is in slope-intercept form, so the number in front of x is going to be the slope. Parallel lines have the same slope, so the slope of our line is going to be 6. And we have this point, x1, y1 is 1, -3, so we just need to plug into point slope form. So the 6 goes in for m, the 1 goes in for x1, and the -3 goes in for y1. Y minus -3 equals 6 times x minus 1. And we're going to simplify a wee bit. Distribute the 6 through. The minus a negative is positive. So 6 times x is 6x, 6 times -1 is -6, and then we're going to subtract 3 from both sides, and we get y equals 6x minus 9er. So that is our slope-intercept form. Okay, B. The line perpendicular to this goes through the point 8, 5. So there's my x1, y1. So, slopes of perpendicular lines are negative reciprocals. So the slope of this line is -4. We can think of that as -4 over 1. So then what's the slope of our perpendicular line going to be? It's going to be the opposite sign, which is positive, and then flip that over and it's 1/4. So our slope is 1/4. Our point is 8, 5. So we're going to plug into point slope form. Y minus 5 equals 1/4 times x minus 8. And then we're going to simplify. Use the distributive property. 1/4 times x is 1/4 x. 1/4 times -8 is, that'll be -8 over 4. That's -2. Then we can add 5 to both sides. And we get y equals 1/4 x plus 3. Alright, so number 6. Pause and see if you can figure this guy out. Alright, so for A, we start with 4x plus 2y equals 7. And we want to get a line parallel to that, but that goes through the point 4, -2. So 4, -2 is going to be our x1, y1. And how are we going to figure out slope? Well, I suppose we could put this into slope-intercept form. If we subtracted 4x from both sides of the equal sign, we would get 2y equals -4x plus 7. And then if we divided both sides by 2, we would get y equals -4 over 2 is -2x plus 7 over 2. So our slope is -2. So now we have our slope and a point. So let's use point-slope form. Y minus y1 equals m times x minus x1. Y minus the y value of the point, which is -2, minus a negative becomes positive. M is -2 times x minus the x value of the point, which is 4. And it says we need to put it in slope-intercept form. So I need to distribute -2x. -2 times -4 is +8. And then I just subtract 2 from both sides to get y by itself. And I get y equals -2x plus 6. Alright, for b, we want to get perpendicular to this line and go through the point 0, 6. This is actually, if you notice, this is actually our y-intercept. So all we need is the slope, and then our y-intercept is 0, 6, so that means our b value would be 6. So we can just use slope-intercept on this one. So what's going to be the slope of our line? Well, if we're perpendicular to a line that has a slope of 2/3, then we're going to be the negative reciprocal of that, so -3/2. Alright, so y equals mx plus b. Our slope is -3/2, and our y-intercept is 6. So that one was easy money. Cool. Looks like we're about done with this lesson. So go ahead and go on to practice 2.4 and formal write-up 2.4. Bye-bye.